Say about Derek, but I think the one I want to say is that he is very lively. I think there's going to be there's always a void when he's missing in the PM session, and he always keeps me on my feet as well. One problem I specifically remember is both of his motors, or one of his motors wasn't working properly, and so he said that he needs to go into some debugging. So I sat back and I relaxed as I watched him fiddle with it. I mean, he just he changed out the wires, he changed out the pin out, he changed the whole entire motor driver, he changed out the batteries, put a new, like a higher voltage batteries, and then finally, after the whole 9 yards, he replaced the motors and it started to work. And so I gotta say, I think you earned your blue stamp stripes, and I'm very proud of you, extremely proud of him for all that he's been through, and yeah, without further ado.
Right, so, hello everyone, my name is Derek, as mentioned earlier, and I'm from Irvington High School in Fremont, California. So, this is my project, which is a ball tracking robot. But wait, there's more. It's a ball tracking tank. So as you can see, there's tank trees over here. And also, you see these two things that look like helicopter blades? These are actually claws that will grab the ball and pick it up when the robot gets close enough to it. So before I explain anything, let me first give everyone a demonstration of how this works. Okay, so right now, before the robot sees anything, it's just gonna turn in a circle, right? Because it's trying to find the ball, but it cannot locate it yet. If the ball is too far from it, because the camera and the detection has a limited range, the ball is too far, it cannot see, right? But if the ball gets closer, it will be able to see it, and it can follow it with surprising amounts of accuracy. And if the ball disappears, it will just turn in the direction in the last time that it will see the ball. So this thing, it follows anything red. So right now it can also follow my shoe. Never sees my shoe. Oh no. Yeah, it's a big mistake. But when, in any case, when the robot gets close enough, it'll be able to pick up the ball. The problem with these servos is that they're a bit weak, but they're pretty strong for their size. And this has been a recurring problem that I've been trying to fix. So, this is basically a basic demonstration of how my robot works. So, a lot of you may be asking, right? How does the robot actually follow the ball? And this, I feel like, is a great question. It has been explained a little bit earlier, but I feel like I need to go a bit more in depth first. So, I have, I'll show you the feed from the bot itself on the computer. Okay. Just one second. Okay, this is good enough. So everyone can see first, on the left side of the frame, we have a frame called draw, and this is the live camera feed from the robot, which has a camera over here. So, it saw the ball. So yeah, I must smile. It freezes a little when it's picking up the ball because it needs to conduct computation on the servos. But this is the live camera feed, so yeah. And next is on the right side is a frame called mask. And so what the mask is it's basically the camera frame, except you apply a color detection script to it. So, as everyone can see over here, if I hold up the ball, it will detect anything red. Right, let me see. If I hold up my shoe, it can detect something red also. So, what it does is mask basically uses every pixel on the camera frame, and if it's within a certain range of red, then it will color it white, but otherwise it will color it black. Sometimes, a lot of times, here, at least this room is pretty clean, but in the other rooms, there's a lot of background noise. So what I do is I implement a for loop. a for loop to eliminate there'd be like a lot of small specks of white over here, because like other small things are white also, right? But we don't want the small specks. So I use a for loop to eliminate all of them to remain only the biggest blob of white, which is then sent back to the camera feed where it draws a rectangle around the biggest blob of white. Using the center of the rectangle, we can determine whether the robot should go forward. It should be saying forward right now. Right or left. And if the speck of red is too small, the rectangle will turn red, which is also something that I coded for. Because you don't want to see something that's really small. For example, my shoe, some red specks on my shoe, and mistake that for the ball. So that is my bot. And some challenges. Okay, so some challenges that I faced during this time were a lot of challenges. But first of all, I like to start off with debugging. So engineering, what you first think of in engineering is like, oh, all sunshine and rainbows, right? You're building stuff, it works, you're very happy, you want to build more. But no, every time something's about to work, it stops working. And this has gone through with me for like, so many times. Thank you to my 4 instructors for bearing with me on this one. Oh yeah, and also for debugging, when I first came into this program, I had like no experience with electrical engineering whatsoever. Like I see wires everywhere. I heard the word EE. It's like a buzzword back then to me. I'm like, oh, I should do that to get a lot of money, right? But no. Right now, I have over here. I learned what electrical engineering was. I also didn't really have much experience in coding, right? Because I came in here with very little Java experience, and this was using Python, which was quite a bit different. And as a result, because I was very inexperienced, a lot of the things that I created were very prone to fault, right? They would break very easily. And even simple things such as like plugging power into ground into power. I think someone else did this here also. And also other things such as when you switch to Wi-Fi, it switches an IP address. Just small things like such as common sense in the engineering world that I also struggle to find. And this kind of brings me to what BlueStamps has taught me. So I came into BlueStamps knowing nothing. If BlueStamps was like crossing a river, I came in here expecting to be put on a boat and transported across with a chauffeur driving me. But instead, what they did, they threw me into the river with a swimming instructor. And not even a life vest, literally. And what the swimming instructor told me to do was swim. So not only did I need to learn how to swim, how to stay alive, but I also needed to learn how to get across. And I feel like this proactivity, right, this motivation, this drive to continue, right, it's what fuels all of us in our like most powerful passions. And it is a very valuable life skill that I've learned here, and that I will also need for future life. So, before I wrap this up, I'd like to give a brief, there's a brief backstory for this modification. So, see the tank trees? Notice everyone else mostly had like 2 wheels. Because there were 2 wheels was driven only by 2 motors, this would be very weak, right? It's very weak, and my robot, see all this chunky stuff up here? It's very heavy, right? So 2 motors cannot carry it. Instead, I wanted to do tank trees, but so what my instructor Terry said was just, okay, I'll give you 1 day to do this. So I ended up staying up until 3, like figuring out how this would work out things. Yes. Another time, what happened was I was fiddling with electricity. So in electrical engineering, the most basic things are power and ground. So in a battery, power is like over here, and ground is like over here. So what I did on the breadboard was power, ground. Guess what I did? Okay, it didn't get destroyed, but I came back after like 2 minutes and the thing was smoking. I was like, oh my god. So, gladly, I didn't lose my progress, and that was a close call, among other close calls that I've had. And I really feel like that I came through here the hard way, but learning things the hard way, you really get to remember them. So, for next steps, if I had more time to work on this project, I'd probably, first of all, I'd see. If everyone can, let's see, once it links up. Okay, so everyone, take a look at this wiring. It looks like a quote from my own instructor, Taran. It looks like a rat's nest. And I feel like it looks like my hair when I wake up. But anyways, I will first clean this up, right? This is very messy, and the breadboard is hidden inside here. So when I need to fix things, I need to like use pliers, and it's very difficult to do. And second of all, I would probably upgrade the modules here. So what I'm using is a Raspberry Pi, which is a computer to program everything. But servos, which are these things that drive the robot arms, these are what make the robot arms move. These work better with another computer, Arduino. And I feel like I could just implement an Arduino system over here to control the servos separately, though this could be investigated further in the future. So that's it for my project now. And does anybody have any questions?
Well, I must say I slightly disagree with your analogy of me running into the river. That definitely did not happen. Is that why your robot, like, what's the distance before your robot thinks that your ball is like another red small object, right?
The robot has the camera and the distance sensor. These are its eyes and ears. Well, you could say these are also the eyes because they look like eyes. But the ultrasonic sensor has a limit of 1 meter. So anything beyond 1 meter, it cannot see. And I say it only reliably detects up to half that. So I cannot use this. I can't directly find the distance. I have to use the Pi camera. So you saw the rectangle I was drawing earlier. Instead of tweaking the distance sensors, which are not very accurate because if you send waves over here, right, they'll just spread out and very little will bounce back, right, from the ball. I edited the size. I'll just look at the size of the rectangle, like look at the area of the rectangle, and I'll adjust that, right? If the area is big of the rectangle, right, if the area is big, that means the ball is closer. If the area is small, that means it's farther away, right? So that's basically how I adjust the area. It's very adjusted distance. It's pretty indirect. Hopefully that answers your question. Any other questions?
Have you tried with the claw on the robot? Have you tried like picking up the balls and just transporting it places? And if you did, how long do you think the claw could carry the ball?
I probably need some stronger servos for this one. But I feel like that's actually an idea that I plan to implement later. Such as I think one of these people here, they were also doing a robot and they had a map. I feel like I could implement some idea like that too, right? Borrow an idea and also make it my own, right? Make it transfer back to me. I feel like that could be an idea also. Any other questions?
How did you come up with the design for your claw? Because I haven't seen many projects or many designs in general use this crab-like.
Oh, crap. Okay. I feel like because servos are, the joints, the servos. So I've been pretty new to them, as I've said before. They threw me into the water. I couldn't do anything. So I was very new with a lot of these technologies. So I see conventional claws like this, or like this. But I didn't really know how to use the servos at that time, so I just came up with this simple foolproof design. Later, maybe I could try changing it up, but this is the most primitive and foolproof one I could come up with at that moment. So hopefully that answers the question. Alright, good. Any other questions?